Welcome to this lesson. I am Siamasaka Kiandens. So I'm going to take you through a lesson for today. Basically, we'll look at questions on the periodic table. Well, these are my contacts. My email address, if you want to contact me, you can use is ksiamasaka@gmail.com, and my WhatsApp number is actually +2609774199949. So actually I provide lessons in physics and chemistry, and at A level I also offer physics, and so I can help you in these areas and other areas not stated here, which you feel I can solve actually equations for you. I can provide actually services in one-on-one online lessons, as well as solving your assignments. I can solve them if you are given assignments and you'd want me to let you actually understand that assignment. I can solve it, as well as I can provide notes on specific topics of your interest, which you feel you need to understand better through a video, as well as barely writing notes. So these are the services that actually I offer. And so here is a periodic table, which will help us and guide us in our question that we are going to solve. We have two elements here, element Z and Q. So these elements are actually presented by the symbols Z and Q. And you note that actually element Z in the first shell, it has 2 electrons. Second shell, there are 8 electrons. And in the outermost shell, there is 1 electron. So this is the electron configuration for element Z. And the element Q, or represented by actually symbol Q, in the innermost shell, it has 2 electrons. And the second shell, which is the outermost shell, it has 6 electrons. So based on these elements, there are questions that have been asked. The first question is that in which group and period are elements Z and Q actually? So for the group, for you to determine actually the group to which that element belongs, you look at the electronic configuration. For Z, as we stated, it is 2, 8, and 1. And therefore, the group is, you have to look at the outermost valence electrons. And therefore, Z actually belongs to group 1. So you look at the elements in the outermost shell. And for Q, we saw that the electron configuration is actually 2, 6, and therefore Q belongs to group actually 6, and we use Roman numerals, so it belongs to group 6. So for the period, we have also to look at the electron configuration. You note that actually Z belongs to period 3 because it has actually 3 shells, because it has 3 shells. And while Q actually belongs to to period 2 because it has actually 2 shells. B, state the valence of Z and Q. Actually, the valence, you have to look at also the number of electrons that are gained. So we said Z actually has the electron configuration 281. Therefore, it is easier for Z to lose one electron. Therefore, valence of Z is actually 1 because it loses only one electron for it to be stable. While Q, we said the electron configuration is 2, 6. And therefore, it is easier for it to gain 2 electrons. Therefore, the valence of Q is actually 2 because it gains 2 electrons for it to be stable. Number C, write a chemical compound formed by Z and Q. The chemical compound would be actually dependent on the valence, and therefore, since we said the valence of Z is 1 and the valence of Q is 2, and therefore, for you to write the compound, this 2 comes there and this 1 comes there, and therefore it will be Z Q. So this is actually the compound. We don't write the 1 there. So this is the compound which is formed. And then G is the compound formed ionic or covalent. Actually, the compound which is formed is ionic because it's formed by one element which loses an electron and the other one gains actually electrons. Therefore, it is an ionic compound. And so we go now to question 2. The diagram shows some elements in the periodic table. So we see these elements here, part of the elements in the periodic table. They are shown. So we look at the questions. What determines the order of elements in the periodic table? Actually, what determines the order of elements in the periodic table, as you can see here, is the increasing number of the atomic number. So increasing the atomic number as it increases, actually, as it increases, it forms actually the order. It forms the order of elements in the periodic table. As you can see here, you note that the atomic number for them is 3, then there's 4, there's 5, 6, 7, and the like. And B, to which period and group does oxygen belong? Oxygen, to which group? The group, it means that we have to look at the electronic configuration of oxygen. Oxygen, as you can see there, it has actually, if you can see, it has the atomic number which is 8. And if the atomic number is 8, it means that its electron configuration, it is 2, 6. And therefore, it belongs to group 2. So oxygen belongs to group 6. And the period for the period actually oxygen belongs to period 2 because it has 2 shells. Okay, oxygen belongs to period 2. It belongs to period 2 because it has actually 2 shells. Number C, which elements belong to groups of halogens and alkali metals? So from here, you notice that actually these elements are known as alkali metals, and these here, they are known as halogens. And therefore, we can say lithium and sodium. So C, lithium and sodium belong to alkali metals, while fluorine and chlorine belong to halogens. So the halogens are actually, that's where there is fluorine. They all actually gain 1 electron for them to be stable. And also the alkali metals, they also lose 1 electron for them to be stable. Okay. D, what is hydrogen? Why is hydrogen not in group 1, although it has 1 electron in the outermost shell? So D, hydrogen actually, though it has only 1 electron in the outermost shell, but it doesn't belong to group 1, because at room temperature, hydrogen is a gas. So hydrogen is a gas at room temperature. Generally, we can say it does not have properties of alkali metals. And so it actually exhibits it shows the properties of nonmetals when it bonds with another nonmetal, and therefore it can't belong to group 1. Okay, so then so we are done with that one. We are done with that one. We go to the other question. The electron configuration of nitrogen is 2,5. What is the valence of nitrogen? So number D, actually the valence of nitrogen, they have said nitrogen actually has the electron configuration 2,5. So what is the valence? It is easier for nitrogen to gain 3 electrons. So nitrogen has a valence of 3. for it to be stable, it requires actually 3 more electrons to make them 8. And so E, how many valence electrons are in nitrogen? In nitrogen, how many valence electrons? There are 5. There are 5 valence electrons. In other words, there are 5 valence electrons. In the outermost shell, how many electrons are there? There are actually 5 valence electrons. Number F, the mass number of nitrogen is 14. How many neutrons are present in a nitrogen atom? So that is number F. Actually, we are saying nitrogen, the atomic number is 7, and the mass number is 12. So how many electrons? So for you to get the number of neutrons, the atomic number is actually the same as the number of protons. So for you to get the number of, you have to actually subtract, okay, the mass number. So it will be actually 14 minus 7, which is actually 7. So there are actually 7 neutrons. Okay. So then that is part of the question is actually answered. G, describe the trend of reactivity in a group of halogens and alkali metals and give a reason for each trend of reactivity. Actually, you notice that for the alkali metals, I'll give you an example. We said lithium has that atomic number, which is 3, and sodium has 11. So electron configuration for lithium, it will be actually 2, 1, while the electron configuration for sodium, it will be 2, 8, 1. And so you notice that actually the electron, the outermost electron in lithium is closer to the nucleus where there are positive protons. Therefore, this electron will be attracted more to the nucleus than that of sodium. And therefore, it is the electron for sodium will easily be actually lost. And therefore, down the group, so down the group actually, we see that this one will be more reactive. Less reactive. The reason is that the electron, this electron, the outward electron in lithium is closer to the nucleus where there are positive protons which actually attract the electrons. And therefore, the trend will be such that down the group, the actually reactivity increases. It increases as you go down the group because actually, as we have indicated, the electron, the atomic number actually increases down the group as you go down the group. And therefore, it means that the electron in the outermost shell, which has to be lost, the little energy will be required to lose it. And therefore, that element will be more reactive. than for lithium, which is actually having the electron which is supposed to be lost, which is nearer to the nucleus where there are protons which are positive. Okay. And for halogens, as we saw the fluorine, if you check the atomic number, it's actually 9. And for chlorine, it's actually 17. And therefore, the electron configuration for fluorine is actually 2 and 7. And for chlorine, it will be 2, 8, 7. So these, they require one electron actually they need to gain one electron for them to be stable. So what it means is that actually the electron which is actually coming in to fluorine actually to easily be attracted because this fluorine has 2 shells, and therefore the protons in the nucleus of fluorine easily attract that incoming electron. And therefore the trend is such that this one will be more reactive, and then this one will be less reactive. So reactivity in halogens, reactivity actually decreases as you go down the group. The reason is that the incoming electron to be gained, actually it becomes further away because of the increasing atomic number. So it is attracted less for it to actually increase the reaction. So for fluorine, it is actually attracts the incoming electron because the protons in it are closer to the incoming electron because of the less number of shells. And so I thought today we can look at these questions. So we'll continue looking at many more questions to help us actually solve many questions as required. So thank you.